So in insertion sort, what we are doing is we are first of all selecting an element. So first of all, in this process, one is selecting one element. Okay, then compare that element with all prior position elements. Okay, so first of all, we'll select one element and we'll compare that element with all prior positions. So the process starts from second element. Okay, now first of all, this is selected. Okay, so this is the current element in first iteration. Okay, this is the current element. Okay, now this element will be compared with this element. Okay, all the elements prior to this. So this element is compared with this element, and here now what will happen? So now here it is compared 64 less than 64 greater than 34. Okay, so here as soon this condition is true, so the swapping will be performed. So 34 and 64 are interchanged, rest all are as it is. Okay, understood.
Yeah.
Now in so that this is second first iteration completed here, right? Now the entire list is copied over here. Now this is the current element. Okay, now this will be compared with all elements prior to this element. Okay, so first of all, this will be compared with this. So 64 greater than 25, true. So the swapping will be performed. Okay, okay.
Yeah.
So basically, what's happening over here is if we see our algorithm over here. So what it is doing is there is current value, and current value is started at index 1. So this range 1 is getting started. Okay, this
Yeah.
range 1 is started, so current index is this. Okay, and when first of all, this is compared with the first element. So whatever the insert value is there, it is compared with that. Okay, so this minus 2 of j, that is I minus 1, is compared with current value. Okay, and then j plus 1 is compared, and then this is being compared with all. So like this, you can see here, and since this is true, so 25 has come here, 64 is here, 34 is already here. Okay, then no, sorry. First of all, it will be compared, 25 will be compared with 34. Sorry. With 34, 25 is compared with 34. So swapping is performed. So 25 has come here, 64 is as it is, and 34 is here. Okay, rest are as it is. Um, Again, now these elements are now this current element is compared with this. Okay, so here now next is 64 greater than 34. So this is true. So sorry, this is true. So 35, 25 is here, 34 is here, and 64 is here. Now rest all will be as it is. Okay. So this is second iteration completed. Now in third or iteration, what will happen is this list has come here. Now this is your current element. Okay, this is your current element, and this element will be compared by this, by this, by this, and by this. Okay. So what will happen? First of all, 25 greater than 12. So 12 will come here, 25 will come here. In second iteration, 25 will be compared with 34. So 34 greater than 25. So what it will do is it will do exchange. So 12 will be as it is, 25 will be here. 64 is already here, and 34 will come here. Okay, now in this, 64 is greater than 34. So now swap will be performed. So 12, 25 are as it is, 34 is here, and 64 is here. Rest elements will be as it is. Is this clear?
Yeah.
Any doubt?
No.
So what's happening is every time one current element is taken, and that element is compared with all the elements prior to that element. Okay.
Yeah.
So this is how this is being recorded. So this will be as it is. Okay, and here now in this is the third iteration completed. Now this was current. Now this is current element. This current element will be compared with first of all this. So there will be no change. Then this will be compared with this. There will be change. So 25 will come down. So here it will be 12. Then 22, 25 will come here. Okay, then 34 and 64. Now in next iteration, 20, yeah, here, 25 greater than 22. Next, 34 greater than 25. Okay, so this will be exchanged. So this is as it is, this is as it is, this will be 25. This is as it is, this is 20, 34. Now, 64 will be compared with 34. So again, this portion will be as it is, this will be 34, this will be 64, and rest will be as it is. Do you understand this process?
Yeah.
Okay, so every time what's happening is it is taking one index as a current element, and compare all the elements at that position with the all previous elements, and then swapping is performed. Okay, so that's only is being processed with this insertion sort. Okay,
Okay.
any doubt?
No.
If you have any doubt, you can ask me. So this algorithm is doing that thing. So this is a current value it is taking. So first of all, it is starting from the position of I, and that value is compared. Okay, as soon it finds that the element at that position is means you can see this is applying the decrementing loop, right? You can apply the increment loop also, you can apply the decrement loop as well, both. So it is basically if it is at second position, it will start from first index to zero index. If it is at third index, it will start from second index to zero index, like that it is doing. Okay,
Okay. Understood.
any doubt in this? Do you want me to navigate each statement with the sorting process?
Yeah.
Okay. So let me copy this. Okay. It is not coming proper. Okay, I'll take it one by one. Okay, so in this process, what it is doing is, first of all, it is selecting the current element. So your loop is starting from I is equal to 1. Okay, so I is equal to 1. So here your second element will be the current element in first iteration. Okay,
Yeah.
the second element is the current element in the first iteration. Now, um, the inside this second loop, what's happening is, means in this, what it is doing is, the element at I, means index 1, is stored in the current value. So value of current val is 34. Okay, now this 34 is compared with I minus 1. So the second loop, inside loop, is starting at I minus 1. So I minus 1 is, so my list of j means I minus 1 is 0. So this is this element is 64. Okay, as per this is 64. So now these two will be exchanged. So 34 has come here and 64 is here. After that, it has decremented to minus 1. Okay, so this was started at 0 at initial process, because this was started at 1. External loop was at 1, so I was at 1, so this was started at 0, and 0 has reached to minus 1, and this loop will be terminated at first. Okay,
Okay.
okay. So this is the one first step. In the second step, the now value of I will be 2. So I is in range. So number of elements. So I is 2. So at current val, in second step, current val will be 25. Okay. Now this 25, first of all, will be compared with 64. Okay, this the exchange will be performed. So at current value, this will be 64 and this will be 25. Okay. Sorry, no exchange is performed here. Here there is no exchange because 64 is bigger. Okay. Then 25 will be compared with 34 in second step. It will be compared with 34 again. Um, now what I am telling. If it is bigger, then swap is being performed. So then this 25 will come at up, and then there will be 34, and third will be 64. Okay, like that. This will keep on working till last. Able to understand?
Yeah.
See, this is a little confusing process, but if you will pay attention small, you will get it through. Right? Now, you have to just understand that from where it is starting and where it is ending. Lot of looping concepts are being used in this. You need to practice those looping concepts.
Okay.
This will only be you will only be able to understand it properly when you will practice it by yourself, because here I can just tell you that what's happening. I can tell you the process. I can tell you the code. But if you just by heart the code, if you try to learn the code, you will not be able to do that, because
No,
lot
I
of
understood the logic. Yeah.
yes, just understand the logic, and you can make your own code as well. Like I have, like this is the decrement code I have used. You can make your increment code as well. So, for example, I can make the increment code as well for you. So, like here, I'll just paste this, and here I can start this loop with 0, and I it can go till I minus 1, not I minus 1. Yeah, it will go till I. Okay, so automatically it will take I minus 1, and loop is of my increment is of 1. Okay, and then yes, dot index 1, and this is I, j in range, j is greater than current value, j my list of j plus 1, j plus 1 and j recent members are compared. Current value, this is my list 2 of I my list my list of 2 of j, and finally I'll do my list of 2 of j is equal to 10. Okay, and then I can remove this part. See, so this is sorted now. Understood?
Okay. Yeah.
This is the same program I have made through the increment loop. This was the decrement loop. The same program is now with increment loop.
Yeah.
Okay, so it depends on how logic you are going to perform. That logic only has to be implemented. So one by one, element will be coming at their own positions. Okay.
Okay.
Any doubt in this?
No.
Okay. So next sorting algorithm is, um, let's say, what else sorting algorithms do you have?
Quick short.
Quick quick sort, merge sort, right?
Yeah. Quick short merge.
Okay, so let us go by quick sort and merge sort. So um, now in quick sort and merge sort, there is recursion is required. Do you remember the recursion? Do you remember the recursion?
Yes, sir.
Okay, so for this, recursion is very much important. How Now let me tell you the process first. What we now follow the process. So in quick sort, what happens? First of all, we have to find a element, and then we have to divide the array based on that. Okay, so like we were doing in binary search, you remember we were finding a middle element, and based on middle element, we were dividing the array into two parts, right?
Yeah.
In the same way, in this quick sort also, we are trying to find a pivot element. That pivot element is the middle element of the array, and with that, we try to divide the array. Um, we try to divide the array, and array is sorted from the middle. Like, mm, let me share the screen again. Okay. So, for example, if we have these elements, let's say we have these elements, okay, and their position is, this is 0, 1, 2, 3, 4, 5, 6, 7. Okay. So at initial, our low is 0, and high is 7. Okay. Okay.
Okay.
And here with the what we do is we find a mid value. So mid value is basically low plus high divided by 2. Okay, so low plus high we do in bracket, and then it is divided by 2. Okay, so basically it will be 0 plus 7 divided by 2. So value is 3.5. So with 3.5, we can say our 4, right? This 4 is the middle value, right? So now we take this middle value. So this is the middle value. And now, sorry, now, what we do is we try to find element. Um, means basically, suppose if we search a element, what to say? Um, mm, how to explain this? So in this, basically, mm, what we are doing is um, low, mid. We are taking, and give me a minute. I'm just thinking how to explain this.
Yeah.
Okay, yeah. So what we are doing is, first of all, now suppose we have the element. Um, Let me take this as okay. Now what we are doing is we are finding a middle element, right? So middle element is, let's suppose that this is at 4. Okay, so no, this is 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now what we are doing is this. We have find this middle element with this low and high concept. We have found that the middle element is at 4. Now this 4 will be compared starting from here. Okay, so here it will be compared. First of all, this will be compared with this. 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 Okay. Um.
Okay.
Okay. So what will happen is in this now. Now suppose when I compare this value with this value. Okay. First of all, I'm comparing these two values. So I'll just highlight. No, I'm comparing these two values. So now here we have found that 64 is bigger. So what we'll do is we'll exchange this. Okay, so now here 22 and 64 rest elements are as it is. Okay, rest elements are as it is over here. Now, now what we are trying to find is now this value compared with this value. So now always the middle value is going to get compared with every other value. So this is compared with this, nothing happens. This is compared with this, nothing happens. This is compared with this, nothing happens. Okay,
Okay.
understood.
Yeah.
Now this will be compared with the further elements. Okay, so now in case of further elements, just opposite will be performed. So now if any value is um, mm, smaller, so basically this sorting starts from the middle. So you can see here the 60 this now 64 will be compared with 11. So this the change will be performed.
Yeah.
Okay, so this will be as it is. 11 will be here, and then 64 will come here. Then this is 9 this 90, and this will be as it is. Now this 11 will be compared with 90, and this I'll highlight this. Now this 11 will be compared with 90, and no change. 11 will be compared with 5. So this 5 will come here and 11 will come here. Okay, so this is the first iteration when all the elements are compared together, and we have find a value over here. So we'll again. Now 5 will be compared with this, then 22 will be compared with this, then 25 will be compared with this. So there will be a time when middle element will come at mid position. Okay, this fourth position. Understood?
Yeah.
After that, this process will be divided. So this part will be different and this part will be different part. Okay. So when middle element will come at this place, all the elements before this will be smaller than this, and all the elements after this will be bigger than this element.
Okay.
Okay. And after that, again, quick sort will be performed separately for this part and this part separately. Okay, because the middle element will come at the middle position, so there will be no change for this element. Okay, now the low and high will be formed again, and then based on that, again a mid position will be decided, and based on that, comparisons will start performing again.
Okay.
Is it clear?
Yeah.
Okay, so like selection sort starts from the first position, then bubble sort starts from the last position. In the same way, this quick sort starts from starting from middle.
Okay.
Okay, so this requires the what recursion. So for that you need to apply the recursion process. So let me draft the algorithm for you, and then I'll explain the algorithm along with this concept. Okay, I'll
Yeah.
just drop the algorithm for you. So this is quick sort. So the specialty of quick sort is the sorting starts from midpoint. Okay, and low and high values are calculated. Once mid value is found, array is divided into two parts, and quick sort is again being performed on both parts separately. Okay, understood?
Yeah.
इसको नीचे कर देते हैं. So once mid value is found array is divided into two parts, and a quick sort is being applied separately in both. So let's see how we are going to implement this. So I am just making a function for quick sort. So this is define quick sort, and inside this quick sort I am passing the array, and low is equal to 0 is always, and with high I am not applying anything for now. Okay, and if high is none. Okay, I'm defining at none at the initial point. I'm defining this value as none. And if high is none, what we'll do is high is equal to length of array minus 1. Okay.
Okay.
So means at initial the high value will be the last value. Okay. Now, if low is less than high, if low is less than high, what we are doing is pivot index. Uh, hmm, pivot underscore index is equal to partition array comma low comma high. I am partitioning the array, and then quick underscore sort. Sorry, quick sort recursion. I am calling array low, and this will be pivot index minus 1. This is first part, and then quick sort array, and low is pivot index plus 1 comma high. Okay, so this is one thing, and now I'm making a function for, so this is partition, so I'm making a different function for the partition part. So def partition, in the partition I'm supplying array low and high, pivot is equal to array of high. I is equal to low minus 1 or j in range low, comma, high, mm, if array of j is equal to or is less than or equal to pivot. Mm, pivot element is this array of I. Starting from low and going till high. Okay, less. Okay, okay, okay. Mm, no. Array of I is equal to okay. This is done. I'm just taking the same list. Okay. Um. So this is done. Now, See, now I have made one function. This is called partition function. This is to divide the array into two part, and then after that, I am using this quick sort function. In this quick sort, I am once this value is low less than high, then these parts are being performed. Okay, inside this partition element, this partition value is being performed. Okay, so now what it is doing is, first of all, there is a slight change in the process. Let me tell you again how this process. So, are you clear with the process how this is being performed?
Yeah,
Okay.
yeah, I understood.
Um, In the algorithm that I have applied, I have changed a small thing in process that will make it more efficient. So what's happening is, first of all, what I am doing is, now this is low and this is high. So what I am doing is, I am comparing the low and high directly instead of any pivot element. I am comparing this low and high directly. Okay. So what I am doing is, first of all, I'm comparing this with this. So these both are, I'm making it this. So this is 5 and this is 64. Rest are as it is. Okay. Now low will be increased and high will be decreased. Okay. Low plus plus and high minus minus I am doing. Now uh, uh, this will means, if you see in the algorithm, what's happening is, this is I is equal to low minus 1 has started, and this pivot is at fixed place. Okay, so whatever the array high point is there, that pivot has been at this place only. So now this will be compared. That means low will be here and high will be here at this place. These two will be compared. So when since there is no change, this will be remain unchanged. Now this and this will be compared, right? So when these two will be compared, this will perform the exchange. So here the 11 will come and 25 will be here. You can see rest elements are as it is. Okay. So now this is low, this is high. After that, now what will happen? This low will be increased and high will be decreased. So this and this will be there. And by this, what will happen? There will be no exchange in this. Okay, there is no exchange here. Now again, low is increased and high is decreased. So now high is at here and low is at this place. Okay.
Okay,
Now, when when low is higher and high is lower, then what will happen? This process, this process will be terminated. Again, it will call the quick sort function again from a new way, and the array will be divided at this point. Okay.
okay,
So this is how this is going to work more efficiently. So you can just revisit how this is working, and if you want, I'll explain this again. This is a little typical process, but once you will practice, you will understand.
okay.
Okay, any doubt?
No, I understood.
If not, I can explain it more. Basically, just you have to consider this: what is the pivot point, what, how low and high is being managed with this pivot index. Okay.
Okay.
Hmm. That's only the thing, is it?
So this can also be written in an iterative loop.
Yes, this can also be written in iterative loop as well. You can write
Okay.
that. But the
And
program will be a little lengthy in iterative
okay.
loop. Hmm. Anything that you are doing with the recursion, that everything can be implemented using the iterative loop as well. But the
Okay.
program will be little lengthy. So if you want, I can implement it for you.
Okay. Yeah.
Okay, so in tomorrow's class, I'll try to show you it, in iterative loop. Okay, so that you will understand it more.
Okay.
Okay.
So tomorrow we will do merge sort and this iteratively for
Yes.
quick sort. Okay.
Yes.
Okay. I'll implement this myself and then ask you if I have any
Sure.
doubt.
Sure. Sure. Okay.
Okay.
Thank you.
Thank you, sir.
Thank you.